All right, today we are diving into one of the most incredible transformations on our planet. We're going to follow the amazing story of how solid, lifeless rock becomes the living soil that keeps us all alive.
I mean, seriously, have you ever really stopped to think about it? We walk all over it every single day, but just beneath the surface, there's a whole complex and dynamic world, and we're about to explore it.
So, this is the big question, isn't it? How in the world do you get from these hard, barren rocks, to this, the rich, dark soil that's bursting with life? Well, it's not magic. It's an absolutely fascinating process that has literally shaped our world. So, our journey actually starts with a little bit of destruction. See, before you can build soil, you have to break down its raw ingredient, and that's solid rock. This first step is all about turning mountains into pebbles. And there's a name for this breakdown process. It's called weathering. And trust me, it's not some gentle thing. It's a relentless force, constantly grinding, cracking, and even dissolving the very crust of our planet. Now, weathering kind of comes in two main flavors. You've got physical weathering, which is basically like taking a sledgehammer to a rock. You end up with smaller pieces, but it's still the same rock. Chemical weathering, though, that's totally different. That's when reactions actually change what the rock is made of. And when we talk about the brute force of physical weathering, we're not kidding. Just think about the sheer power of water getting into a crack, freezing, and expanding like a wedge, or wind blasting sand against a cliff face for 1,000 years. Even a tiny plant root has the slow, steady power to split a boulder in two. It's just a constant physical assault. This quote right here just nails it. It's the perfect way to picture chemical weathering. You know, even normal rainwater is a little bit acidic. And over thousands, even millions of years, that rain slowly dissolves certain minerals, weakening the rock from the inside out until it just crumbles. It's a silent, chemical attack. Okay, so the rock is officially broken into bits and pieces. But they don't just hang around. Nope. The next chapter in our story is all about movement. And we're talking movement on a massive scale. And that movement is called erosion. Here's a great way to remember the difference. If weathering makes the mess, erosion is what moves the mess somewhere else. And as you're about to see, nature has some seriously powerful tools for the job. The forces behind erosion are just relentless. You've got wind, which acts like nature's sandblaster, carrying tiny particles that can carve these incredible, delicate arches over millennia. Then there's water. A simple river, over geological time, can carve out something as mind-bogglingly huge as the Grand Canyon, moving just an unbelievable amount of rock and sand downstream. And of course, you've got ice. We're talking massive glaciers acting like planetary bulldozers, just scraping the land bare and pushing mountains of rock across entire continents. So we've broken the rock down, we've moved it all over the place, and now the real creation begins. With all these tiny rock fragments gathered together, the stage is finally set for that rubble to slowly become a life-giving resource. But it is so important to understand the timescale we're dealing with here. Just look at this number. It can take over 100 years to form a single inch of topsoil. That's just wild. We're talking about a process that spans multiple human lifetimes. And here's where it gets really interesting. When you look at what soil is actually made of, it's probably not what you'd expect. Sure, almost half of it is minerals, that's the rock dust. But check this out, a full 50% of healthy soil is just empty space filled with air and water. And that tiny little 4% sliver of organic matter, that's the secret sauce. That's what brings the whole thing to life. So you can think of it like a recipe with 5 essential ingredients. You start with your base, the parent material, the kind of rock it came from. You add topography, the shape of the land, and climate. Then you mix in the living component, all the plants, animals, and microbes. And finally, the most important ingredient, you let it all cook for a very, very long time. Now, as the soil develops over all that time, it doesn't just form one uniform pile. It does something really cool. It organizes itself. It creates this hidden, layered structure, like a cake, right beneath our feet. Scientists call each of these distinct layers a soil horizon. And every single one has its own unique color, texture, and chemical makeup. Each layer tells a different chapter of the soil's life story. Let's take a quick tour from the top down. At the very surface, you've got the organic layer, decaying leaves and stuff. Right below that is the dark, rich topsoil. That's the powerhouse, where most of the life happens. As you go deeper, the layers get lighter and rockier, moving through the subsoil and broken up parent material, until you finally hit solid bedrock at the bottom. Okay, so we've gone all the way from solid rock to rubble to this incredibly complex layered system. But why does any of this actually matter to you and me? Well, the answer is it matters for pretty much everything. This right here is the big one. Just let that number sink in. 95% of the food we eat comes from the soil. Whether you're eating a carrot or a steak from a cow that ate grass, it all traces back to the soil. It is the absolute foundation of our global food supply. Plain and simple, without healthy soil, we don't eat.
But it doesn't stop at food. Soil is also our planet's water filter. As rain seeps down through all those horizons we just talked about, the soil acts like a giant natural purifier. It cleans out impurities, and that water eventually becomes the clean drinking water in our wells and aquifers.
Which brings us to our last and most critical thought. We've seen that soil gives us our food and cleans our water. We know it takes centuries upon centuries to build, and yet in many places we're losing it in a matter of decades. So the question we have to leave with is this: what happens when it's gone? And how do we start protecting this fragile, living foundation beneath our feet before it's too